Today, we're going to talk about one of the most fundamental forces in the entire universe, gravity. But we're going to look at it through a really fascinating and, honestly, pretty critical lens. It's a perspective that argues modern physics might have completely overlooked the profound wisdom of the guy who started it all, Isaac Newton.
Okay, so let's just dive right in with this powerful idea from our source material. It doesn't just frame Newton as a brilliant mind. It says his real genius was in what he refused to claim. You know, this caution, this deep respect for the mysteries of nature. That's the key to unlocking a totally different way of thinking about gravity. All right, so here's our roadmap. We're going to start with Newton's really careful insights. Then we'll see how our source challenges a core principle of modern physics. After that, we'll investigate its claims about the fabric of spacetime itself, look at its alternative vision, and finally, explore why it believes gravity is just uniquely strange. So let's start right there with Newton's whole approach. The argument here isn't just about what he discovered. It's about the massive importance of what he chose not to conclude, a distinction that our source actually calls doubly brilliant.
And this is the key point the source makes. Newton was totally aware of the parallels between gravity and acceleration. I mean, he even used them to figure out how satellites could work. But he very deliberately stopped short of saying they were the same thing. And it's that precise, careful distinction that our source holds up as his divine genius.
And you know what? That cautious distinction leads us straight into the heart of the whole debate. This next part pits a huge cornerstone of modern physics against a very direct, almost common-sense counter-argument from our source. So on one hand, you've got the equivalence principle. It basically says that standing in a gravitational field is indistinguishable from being in, say, an accelerating rocket. But our source material says that this whole argument completely backfires. It claims the fact that we feel weightless in free fall while we are definitely still accelerating is the ultimate proof that gravity and acceleration are not the same.
To really make this point stick, the source gives us this little thought experiment. Imagine you're in space and some force starts accelerating you. You would feel it. You'd feel that push, right? But when you're just under the influence of gravity, like standing here on Earth, you don't actually feel the pull. You only feel the ground pushing back up at you. The experiences, it argues, are fundamentally different.
So then the source uses the classic elevator example to try and hammer this point home. It argues that because your weight on a scale changes when you accelerate up or down, the experience can't be identical to the constant feeling of gravity. Now, it's worth pointing out that the source's premise here is a bit flawed. Accelerating down in an elevator actually makes you feel lighter, not your normal weight. But based on its own interpretation, the source concludes that these sensations are proof that gravity and mechanical acceleration are two different things.
So after challenging the equivalence principle, the source now takes aim at what it sees as an even more radical, almost unbelievable concept in modern physics, the very nature of space-time itself. I mean, this is the fundamental question it poses. We're not talking about what's in space, but about the container of the universe itself. Can something we think of as just emptiness actually have properties like curvature?
And while the author's position is pretty clear, as you can see, the whole idea that space can be bent or warped by mass is rejected in the strongest possible terms. It's framed as an assertion that just completely defies basic logic.
The reasoning for this rejection is actually pretty straightforward, based on the laws of motion. If space had any kind of substance, if it could be bent, it would have to be a thing. And if it were a thing, it would create resistance, right? A kind of cosmic drag that would slow everything down, making the endless orbits of planets impossible, and getting rid of the whole concept of inertia as we know it. Okay, so if the source rejects this idea of a bendable fabric of spacetime, what does it propose instead? Well, it lays out a very clear alternative definition, basically a return to a more classical view of space. And this is the foundation it proposes. No four-dimensional space-time, no weird curvature, just a simple, absolute stage where all the events of the universe play out. It's a container, not a participant. And from this viewpoint, these are the fundamental rules of the game. Space is the prerequisite for matter, not the other way around. Its three dimensions are just a direct reflection of the fact that matter itself is three-dimensional. And, most importantly, it's passive. It's just empty, infinite, and totally unchangeable. So, after rejecting modern physics explanations for space and gravity, the source comes back to the force itself, and it wraps things up by highlighting what it sees as gravity's unique and just deeply mysterious properties.
And this slide really sums up what the source thinks are the core mysteries here. Unlike magnetism, gravity's pull doesn't get stronger with speed. It acts on an entire body all at once, pulling every single atom equally. It's also incredibly weak, which is what allows objects to travel these huge distances unimpeded. The source calls its behavior a divine elasticity, this constant, unwavering influence that doesn't build up, letting a spacecraft swing by a giant like Jupiter and escape just as easily as it went in.
And that brings us to the final challenge, a challenge to our own perceptions, based on the source's main argument. We're being asked to just trust our senses. We feel the push of acceleration, but we don't feel the pull of gravity. So if that's true, then this whole perspective leaves us wondering all over again about the true nature of the most familiar, yet maybe the most mysterious force in our entire universe.